could get asked. This one on pendulums. Plan an experiment to investigate how increasing the length of a pendulum affects the time period for one complete oscillation. And then the wording could be different, but it's likely to follow the structure of a standard experiment. In a normal experiment, you would want title, aim, variables, a list of apparatus, a diagram, steps, a results table, graph, and a conclusion. In another lesson video, I explain in detail all of these components, so here I'm just going to focus on this particular question. It's always a good idea to start off by identifying dependent variables. You can play along. What do you think the independent and the dependent variables are? So looking at the question, length of a pendulum and time period for one complete oscillation. And the controlled variables? Aim for two good ones. I'm going to pick the mass of the pendulum and the angle of the swing. There are others, but you would lose marks if you don't mention the mass. That's an important one for this particular question. So now I've got the variables sorted, I can think about the experiment. Those variables again up here. Okay. I'm going to sketch the apparatus because drawing helps get the basic ideas out of my head, and then that lets me use my brain for the harder things. There's a string, a pendulum bob, a stand and a clamp. It's not just going to float around there. I should have a stopwatch, but I'm not going to draw. And we're going to add a marker, a pointer, a fiducial marker also called, and I'm going to put it here. Now many people would actually choose to put it over here. There's a couple of very not so good. Any thoughts? Why does placing the marker in the center allow for better accuracy? Well, one reason is that after starting the pendulum swinging from here, it would never actually get back to this point again, which kind of having a marker. Also, if the pendulum does swing close up here, it's traveling very slowly at this point, so it's difficult to know when it actually stops. To judge the time when the pendulum stops. In the middle, it's easier to judge when it gets past. You do get reaction error, but nothing's perfect. Onto the steps. Set up the apparatus. Okay, you don't need to write that, but writing down one line can help you write the second line. So it's a good idea to put it down to get you started. Adjust the pendulum string so it's 10 centimeters long. Alright, so I've got a nice sensible length, and I've also mentioned the apparatus that I'm going to use. Move the pendulum 3 centimeters to the side and let go. Why does everyone do massive swings? Not only does it break the mathematics behind it, but the swings go funny as well. When the pendulum passes the center, start the stopwatch. Okay. There. Count 10 complete oscillations and stop the stopwatch. Okay, that's clear. And it's also mentioning the apparatus again. Repeat 2 more times and get... Okay, repeating's always a good idea. Calculate the time for one oscillation by dividing the time taken for 10. We're getting the real dependent variable. Repeat 5 times, increasing the length of the pendulum by 5 centimeters each time. Okay, we need to get enough results to get a graph, and I've also specified how much I'm increasing by for that extra. Plot a graph of the length of the pendulum against the time period. Okay, so that's going to give us information for the conclusion, especially if we got, as I mentioned. So there you have it. I've covered all the criteria that are set in the examination question, but I've written it as a nice detailed experiment, and I've done it in the style of a normal experimental report. Key skill of writing experimental reports rather than just simply trying to answer an exam question.